Imagine you're standing on a big mountain, but you're blindfolded. You can't see where you're going. You can only feel the slope under your feet. Your goal? Find the very bottom of the valley. That's basically what gradient descent does inside of a neural network. It helps the model find the lowest point, where its predictions are most accurate. Let's break down how it actually works step by step. No math, just intuition. But before we explain how gradient descent works, let's talk about why we need it. In machine learning, a model learns by adjusting numbers called weights. We can think of weights like little knobs that control how much importance it gives to different inputs. The goal is to find the best combination of these weights so the model's predictions match the real answers as closely as possible. You can imagine this curve as a map of the model's error. High up on the hill means lots of mistakes. Down in the valley means the model is doing its best with minimal error. So the model's job is to find that lowest point. But it can't see the whole mountain like we can. It has to figure out which way leads downhill, using only what it can feel at its current spot. That's where gradient descent comes in. Here's how the process works in simple terms. Each time the model takes a step, it checks how well it's doing. That's measured by something called the loss. Loss is basically how far off the model's predictions are from the correct answers. Then it measures the slope of that loss curve. This slope is called the gradient. The gradient shows which direction makes the loss go up and which makes it go down. We then adjust the model's weights, those internal knobs, in the opposite direction of the gradient. That's how the model moves downhill, reducing its error each time. So how big of a step does it take? The step size is determined by two things, the gradient and the learning rate. First is the gradient steepness. A steep slope wants to take a big step, and a gentle slope wants to take a small one. Second is the learning rate, which is a single number that controls the overall size of every step. It's like how fast or slow you've decided to walk downhill. Finding the right learning rate is critical. Let's see what happens when the learning rate isn't quite right. On the left, this ball takes huge steps. It overshoots the valley, bouncing back and forth, never settling down. On the right, the ball barely moves. It's crawling slowly toward the bottom, but right in the middle, that's the sweet spot. Smooth, steady descent. The learning rate controls how confident the model is when adjusting its weights. Too confident and it keeps skipping past the answer. Not confident enough and it barely learns anything at all. Finding that balance is key to training neural networks efficiently. Now imagine, instead of one hill, there are millions. That's what happens in real neural networks. Each weight adds another dimension to this landscape. Gradient descent helps the model adjust all those weights together, like rolling down a mountain in millions of directions at once, until it finds the lowest possible point where it performs best. This is the core of learning in AI. Gradient descent is how machines improve from experience. And that's gradient descent, one of the simplest but most powerful ideas in AI. Next time you hear about a neural network training, picture that little ball rolling downhill, step by step, finding its best path. If this video made gradient descent finally click, make sure to hit that like button, subscribe for more clear breakdowns, and comment below what you want simplified next. And as always, I'll see you in the next video.